the lesson 27 college algebra demo. So the example that we just explored in the preview exercises where we were talking about median salary and a 3% yearly raise, that is meant to introduce us to the idea of a quantity growing at a constant percent rate. Money often does this. Functions that increase at a constant percent rate are called exponential functions. So let's see if we can develop a general formula for the median salary example given in our preview exercises. We want a formula for S in terms of T. S will be salary. T is the number of years since 2014. So new salary after 1 year. The way we calculated it is we took 100% of our original salary and we added 3% of that original salary, which comes out to a total of 103%, right? So we, as decimals, that would be 1 plus 0.03, 1.03. Meaning 103% of the original salary, which gives us the 41,000, can't remember the value, 41,777. All right, after 2 years, this is our 41,777. That's just the way we calculated it. And then we add to that another 3%. And when you simplify, we end up multiplying our original salary by 1.03 squared. We end up multiplying it by 1.03 twice. You multiply by 1.03 for the first year, then you get another 3% raise, so you multiply by 1.03 again. So our new salary after 2 years is 40,560 times 1.03 squared, because the salary has increased by 3% twice. So to calculate my salary in 3 years, I could do 40,560, my original salary, and I'm going to increase it by 3% 3 times. So I multiply by 1.03 cubed. 5 years, 40,560 times 1.03 to the 5th. Give yourself a 3% raise 5 times. So you multiply by 1.03 5 times. Similar for 10 years. Multiply by 1.03 10 times. That's 1.03 to the 10th. And then for T years, we just follow this pattern, and we multiply by 1.03 T times. So in general, the salary function can be written as an initial salary times a growth factor, which in our case was 1.03, raised to the T. Because you multiply by that growth factor, T times. All right, the general definition of an exponential function when you're modeling data would be f of t equals a times b to the t is your formula. And a can't be 0 or else the whole function is 0, and b has to be positive. A is always going to be your initial value, the value when t equals 0. And b is the base of your exponential function, is also called the growth factor. The growth factor is found by taking 1 plus your percent growth rate or growth decay rate. In the salary example, that was the 0.03. We were growing by 3%, so my R was 0.03. So my growth factor was 1 plus 0.03. If your growth rate as a percent rate of change, R, is positive, and that would make B bigger than 1, then you have exponential growth. If your percent rate of change is negative, so your an investment you made is actually decreasing by 2% every year, right? Then your R would be negative 2%. Your B would be between 0 and 1 because you're adding a negative number to 1. And in that case, you get exponential decay. Keep in mind that some definitions for an exponential function, including the one of our textbook, just automatically sets a equal to 1, and they think of a as a vertical stretch or shrink by putting in different a's. And so they define an exponential function as f of t equals b to the t. And we're going to look at a couple of examples and talk about is it growth or decay, what is the factor, and what is the percent rate of change. So if f of t equals 2 to the t, We could also think of this as 1 times 2 to the t. So my a value is 1 and my b value is 2. Okay, so when b is bigger than 1, my growth factor, you're multiplying by something that's bigger than 1, everything's going to get bigger at each step. So this is growth. My growth or decay factor, that's b, in this case is 2. So my constant percent rate of change, if you're multiplying by 2 at every step, let's think of it in terms of salary. If you multiply your salary by 2, it doubles, right? So your salary goes from 20,000 to 40,000. That's a doubling, which is a 100% increase in salary. All right, let's look at the next function. P of t equals 100 times 1.012 to the t. So if we think of this as a financial function, this says we're starting with $100 and we're multiplying that by 1.012. You multiply by a number bigger than 1, the answer is going to get bigger, right? The answer is going to be bigger than 100 if you multiply 100 times 1.012. So that means I've got growth. My b value is bigger than 1, so I have growth. And my growth factor is 1.012. That's my b value. Which means that my percent rate of change is ignoring the 1, right? That means that the 1 means I get to keep 100% of what I had before, and then I get an additional 1.2%. Right? Think of that 0.012 decimal and change it to a percentage by moving the decimal point 2 to the right. 1.2% growth. All right, G of t, 200 times 0.886 to the t. So again, think of this as representing money in a bank account or in some investment. So we start with $200, and then you're going to multiply 200 by 0.886. So you're multiplying by a number smaller than 1, which means the amount is going to shrink. Let's just see what happens when I multiply 200 times 0.886. Oops, I missed a decimal. 200 times 0.886. I get $177.20. So the amount of money in my account shrank. So this is decay. Right? Whenever your b value, this thing that you multiply by, is less than 1, you have decay. My decay factor is just the b value, 0.886. And then if I think of that 0.886 as the amount of money I get to keep, right? I start with $200 and then I get to keep 88.6% of it. I'm multiplying by 88.6% and that's how much is in my account at the next step. So if I'm keeping 88.6%, that means that I'm losing 11.4% at each step. So that is my percent rate of change is negative 11.4. Right? I'm decreasing by 11.4% at every step.